Hi there and welcome to our first lesson of electrostatics, and this is going to be a very simple lesson where I'm going to talk to you about electric charge. Now, what do we mean by an electric charge? Well, a charge is defined as having an excess, so a charge is an excess or lack of electrons compared to protons Now if we have a negative charge, okay, so a negative charge, it simply means that I have more, so my electrons are in excess. Electrons are more than my protons, okay? Protons. And if I have a positive charge, then it simply means the opposite, that my electrons are less than my protons. So what we'll do is we will define charge completely in terms of electrons. And since electrons are very, very, very small particles, instead of considering each electron as a charge, we will consider a group of electrons. And we've looked at this in a previous video on electricity, a group of electrons called Coulomb. Now, Coulomb is just a quantity. It is a collective name for 1 comma, is it 1 comma? No, it's not 1 comma, it's 6 comma 241 times 10 to the power of 18. Okay, so 1 Coulomb, and we use the capital C to represent 1 Coulomb, is this many electrons. Okay, does that make sense? So it's 6,241 and another 15 zeros. Why 15? Because I'm moving the comma 18 times 1, 2, 3, and another, there's no more letters or numbers, sorry, so I will add zeros, 15 zeros, because I've already moved the comma 3 times. That's how many. 1 Coulomb is that many electrons. Okay, now what you need to understand is that a Coulomb and electrons have negative charges. So 1 Coulomb will be this many electrons. Now if it is positive, then obviously I'm talking about electrons in the negative. In other words, I've lost electrons. But let me quickly, before I get there, actually just show you, if 1 Coulomb is this many electrons, and a Coulomb is the unit for charge, okay, then what is the charge on an electron? So what we'll do is we'll simply just get in this expression, we'll divide both sides so that we can get the electron by itself. We'll divide with 6,241 times 10 to the power of 18 on both sides. 6,241 times 10 to the power of 18. So what do we then get? We get 1 divided by, and let's put that in brackets, 6,241 times 10 to the power of 18, and our answer is, okay, equal, oh there we go, 1,602 times, and this is just the way that a calculator, or especially the one on a computer, would express 10 to the power of negative 19. That's what this little e represents, 10 to the power of negative 19. So 1 electron has a Coulomb charge of 1,602 times 10 to the power of negative 19 coulombs. And now what you should remember is that an electron has a negative charge. So we'll just put a negative in front of that. If it's a positive charge, we'll give it a positive. So if I wanted to calculate the charge on any element, okay, we'll use Q to represent, Q represents charge. Q is for charge, and the unit charge. Then all I'll do is count the number of electrons in excess or in lack, and that will be represented by N. So N is the number of electrons in excess or in lack. So the charge of that object, an object that has more or less electrons in than it has protons, will then be calculated by multiplying N with E. So if I have electrons in excess, and if I say N with E, I mean the charge on electron. And I think the charge that an electron has, instead of using E, because E just represents an electron, then the charge on an electron is just Q. Okay, so Q is the charge of one electron. Capital Q, that's lowercase q. Capital Q is the charge of an object that has lost electrons. So Q is a constant, and this is the constant. If you forget where the constant comes from, it's just 1 divided by the number of electrons in a Coulomb. Okay, so this is actually not correct. It should actually be N times Q, where Q is the charge of one electron. Now, if we have an excess of electrons, then N will be positive. If we have a lack, then N would be negative. Okay, so the charge is negative. So if we have N is positive, so we have an excess of electrons, then we'll have, so then Q will be negative. If we have a lack of electrons, then N is negative. N is negative. Q is by definition negative, so negative and negative will give me positive. So if I have a lack of electrons, I've lost electrons, then I will have a positive charge. Okay, now finally we get to a theorem. And this theorem is called the principle of conservation of charge. Now this says in a closed system, okay, what we mean by a closed system, no electrons are added or escapes. Okay, in a closed system, so I can have 100 objects, but I consider all of the 100 objects as one system, and each then the quantity of electrons that all of them have, when I add it together, okay, at no point can there be more or less electrons. That's what we mean by no electrons are added or escapes. It doesn't mean electrons don't go from one object to another object. It simply means that in the system the total electrons stay the same. In a closed system, the net charge of the system remains the same. The net charge of the system remains the same. And the net charge of that system, okay, the net charge of the system is equal to the sum of all the charges. Okay, now some charges might be positive, some might be negative. So some charges might completely cancel one another out. So if I have a 6 Coulomb charge and I have a negative 6 Coulomb charge, then if that was the only two charges, then the sum of all the charges would equal 0 Coulomb. So the net charge of the system would be 0 Coulomb. And it doesn't matter what happens in that system, what I do with the electrons. So let's say I've got two objects. Here's one object and there's another object, and the one has 7 coulombs, the other one has negative 5 coulombs. If 1 coulomb of electrons, because this one has it in excess, goes that side, okay, then the net charge of this system is 2 coulombs. It doesn't matter what happens in the system, before and after, the net charge must be 2 coulombs. So for example, if a coulomb of electrons go that side, then I've got negative 5 becomes now negative 4 because I've lost electrons. I get a more positive charge. So afterwards I will have negative 4 coulombs, but I must still have 2 coulombs as a net charge. So this one must still be when I add them together at negative 2, so this one will become 6 coulombs. And now you'll see when I add it together, I still have a positive 2 Coulomb charge. Okay, notice that. So even if electrons gets moved, now what we could notice, another law, is that when two charges interact, I don't know if that's the correct word, when two charges interact, then electrons will be changed, let's say exchanged, so that the final charge on each object will be the same. Okay, so what do we mean by that? Well, if I were to take two objects, okay, here's my object 1. Sorry, that's not the object. Here's my object 1, and here's my object 2. These two have two different charges. Okay, so this one has a charge of n coulombs, and this one has a charge, maybe n is the wrong, let's say rather s coulombs, and this one has a charge of t coulombs. So when these two touch each other, because they have different charges, the one might have a positive charge, the other one might have a negative charge, and as a result, because they have different charges, they will attract or repel one another. But if they touch after they have come into connection with one another, electrons will swap so that they will have the same charge afterwards. Both of them will have the same charge. So what we'll do is, what is the charge of the system? The charge of the whole system is the sum of the one plus the other one. Okay, so in other words, S plus T Coulomb. And now each of them, that's the whole system, after they've connected, each of them must have the same charge, which means afterwards I will have that the sum of the two will have, each of them will have half the charge compared to the whole system. So we will have, the one will have a charge of half of the sum of these two, and the other one will also have the sum of half of those two, because they must have the same charge, and yet the charge of the system must still be the same. Does that make sense? So basically it comes down to this, that if I have two charges, Q1 plus Q2, if this is my initial charge, this is initial, then the final charge would be Q1 plus Q2 divided by 2 plus Q1 plus Q2 divided by 2. I will have two new charges. This is my final charge for object 1. This is my initial charge for object 1 and my initial charge for object 2. Then the final charge would be these two initial objects added together and divided by 2. So let's take this, for example, this one as an example. If these two were allowed to touch each other, then what will happen is the excess electrons here will jump to that side. And that is where, if you've seen an electric spark, that's exactly what happens, is electrons jump from one object to another object, and that causes a spark. Now if this -5 Coulomb were to come close enough, the attractive force on the 7 Coulomb will attract it so much that it will fly through the air and cause that blue spark. Now what will the final charge be on this system? Well, we'll add them together, and we saw that the total system has a positive 2 coulombs. Okay, that is for the total system. But how much will each object now have is that total. I've added them together, 7 plus the -5 gives me positive 2, and now I divide it by 2. So the one object will have a 1 Coulomb charge, the other object will also have a 1 Coulomb charge. Very easy. If objects were allowed to touch, their final charge would be the average of the charges that they originally had. Okay, just add it together and divide by 2. Well, thank you very much for watching. I don't think this is a very difficult topic, and I hope I didn't make it any more difficult than it should be. So let's just quickly revise. An electric charge is when I have an electrons in excess compared to protons, or in lack compared to the protons. A group of electrons called a Coulomb is 6,241 times 10 to the power of 18 electrons make up 1 Coulomb. So if I divide both sides here, that gives me the constant Q, which is the charge in coulombs of one electron, which is negative, because electrons have negative charges, 1,602 times 10 to the power of -19. So if I wanted to know the charge in coulombs of any object, I just simply count how many electrons does it have, or how many electrons did it lose. And I call that N. If I got electrons, N would be positive. If I lost electrons, N would be negative. Then I multiply N with this charge, and that will give me the charge on an object. Okay, the principle of conservation of charge says if I've got more than one object, then in a closed system, in other words, no electrons are being added to the system or subtracted. It doesn't mean the electrons can't jump between objects, but there's no extra electrons added to this to the system, and therefore it makes sense that the net charge of the system must remain the same. In other words, if I add up all the charges, I will get what is called the net charge. Now, if I add up all the charges in a system, that's the net charge before there's any interaction. If there is any interaction, then the charge afterwards will simply be the average of the net charge that I calculated, and the charge on each object will be the same. In other words, final charge, I didn't write that here, but final charge of one object will equal to the final charge of the other object always. So thank you very much for watching. We'll see you in the next video.